Hi everyone and welcome to my channel. In this video I want to talk about very important object-oriented programming concept, which is abstraction. So in this video I am going to explain what is abstraction, and then I am also going to show you how you can implement and use abstraction in C++ programming language. But before I continue with this video, I would like to take a brief moment to introduce C++ Builder. It is full-featured C++ IDE that helps you create apps fast for all major platforms while writing less code. It connects natively to almost 20 databases like MariaDB, Oracle, SQL Server, Postgres, and many more. The key value is C++ Builder's framework, which are powerful libraries that do more than other C++ tools. This includes the award-winning VCL framework for high-performance native Windows apps and FireMonkey framework for cross-platform UIs. Smart developers write better code faster, and you can start for free using the link in the description. So in programming, abstraction means showing and displaying the important information while hiding the unimportant and complex details. Now, the best way for you to understand how abstraction works is using a real-life example. So, imagine, for example, how a coffee machine works. The only thing that you need to know in order to be able to use a coffee machine is that you put inside coffee and water and you press a button, and that is how you make a coffee. Now, that process internally is very complex, so the way that internal components of that coffee machine work together in order to prepare that coffee, that is very complex. But you don't need to understand that. That process is abstracted for you, and it is hidden behind simple procedure, which is put in coffee, put in water, and press a button. And that abstraction makes it very easy for you to use a coffee machine. And that same thing happens with the code. So when developers write the code, they should try to write it in a way which makes it very easy for other developers to use. And in order to achieve this, in programming we use abstraction. So we hide complex details behind simple procedures. Another idea is that the things that are abstracted don't change very often, or at least they don't seem to change for the end user. What this means is that you can change the entire implementation, which means you can change that complex logic that is in the background, as long as you don't change the interface towards the user. So as long as you don't change that abstracted level, nothing has changed for your end user. So imagine the following situation. Let's say that a new company figures out a better way to make coffee machines, so that those coffee machines spend less energy, they make coffee faster, and they are less noisy. So what they need to do is they need to implement very complex logic. They need to change the way that these inner components of a coffee machine work together in order to make coffee faster, in order to make that machine less noisy, and in order to spend less energy. They need to change that internal logic, but as long as the interface towards the user stays the same, so as long as our user needs to put in coffee and water and press the button, nothing has changed for the user. So he does not need to learn the new way to use that new machine. He uses it the same way that he used the previous one, even though this new machine is better. So it is less noisy, it is cheaper, and it makes coffee faster. Now, once a certain behavior is abstracted to the point where it is very easy to use for the end user, then the abstraction becomes a standard, which means that then users expect to press a button and make a coffee, or to press a button and take a selfie, or to push gas pedal and make their car go faster. Even though all of these processes, all of these procedures are much more complex, our end user does not need to know anything about that complexity. So once we have this standard, then if a new company appears and that company wants to make smartphones, for example, that company knows that, hey, there is this standard, there is this contract that says that if a user presses this button, that means that he wants to take a selfie. So now it will be up to that company to make and implement that complex logic of taking a selfie and then to hide it from the end user, so that the only thing that the end user knows is press a button, take a selfie. Because if they make it so that the user needs to press 3 buttons in order to make one selfie, then no one will want to use their smartphone. So the same way that you can in real life create this abstraction layer which hides all of the complex details in the background and then displays only the important information, you can do the same in programming. So I, as a programmer, if I create a class that implements a lot of different functionalities which are very complex, and then other developers wants to use those functionalities, what I can do is I can say, hey, I am going to provide you with this abstraction layer, and that abstraction layer will hide all of this complexity in the background, and then I am going to show you only the important information, so only the functionalities that you can use inside that class, and you don't really need to know how those functionalities are implemented in the background. So you don't need to know anything about that complex logic, but here is only a simple interface that you can use in order to access those functionalities. So, in order to implement this abstraction layer in C++, we use abstract classes, and an abstract class in C++ is a class that has at least one pure virtual function. Now, if you are not familiar with abstract classes and pure virtual functions, I am going to link a video here, and then I will put it also in the description, so make sure to watch that video first because it will help you to understand what I am talking about better. So what I want to do now is I want to create an abstract class which will be called smartphone, and that abstract class will represent this contract, which means that inside that abstract class I will declare important functionalities that all smartphones need to have. So let's jump inside our Visual Studio and let's do that. So let's create a class called smartphone. I will say class and then smartphone, like this. And what I want to do inside this class is I want to declare one public functionality which will be called take a selfie. So public and then void take a selfie, like this. Now, in order to make this class here an abstract class, what we need to do is we need to have at least one pure virtual function inside that class. So we will make this function here a pure virtual function. Again, if you are not familiar with virtual functions, pure virtual functions, and abstract classes, I will link a video in the description, so make sure to watch that video and then come back to this video. So, in order to make this function a pure virtual function, first of all, you add virtual keyword here, and then you say that it is equal to 0, like this. So by doing this, this class here has become an abstract class, and that means the following. First of all, we cannot create instances of abstract classes, but we can create pointers of abstract classes. And then this function here, this take a selfie function, will not be implemented inside this smartphone class. So smartphone class will not provide the implementation for this function here, but whoever decides to inherit from this smartphone class will need to provide their own implementation of this function here. So now our smartphone has become this abstracted layer. Now our smartphone class is this interface which says, here are all of the important functionalities that smartphones need to have. So whoever wants to use a smartphone, here are all of the functionalities that you can use without knowing the logic of how those functionalities are implemented. And then whoever wants to make a smartphone, you need to implement this complex logic for all of these functionalities here. So now what I want to do is I want to create a specific type of smartphone. So I want to create Android smartphone, for example. So that means that I will create a class called Android. So let's do that. Let's say class Android, like this. And what I want to do for this class here is I want to say that it signs this contract called smartphone. So how do we do that? Well, it's very simple. You just inherit from this class here. So let's do that. Let's say inherits publicly from a class called smartphone. Let me copy this. Okay, so by doing this, by signing this smartphone contract, what we have said is that we will implement all of the functionalities that this contract here implies, and that is only one functionality called take a selfie, because if we don't do that, we will not be able to use objects of type Android. So let's demonstrate that first. Let's create a smartphone pointer and let's call it S1, so smartphone 1, and I will say that it is equal to new Android. Okay, and we are able to do this, so we are able to make a base class pointer point to derived class, because this Android is a smartphone, because it inherits from a smartphone class. So Android is a smartphone, and because of that we can use a base class pointer in order to point to an object of derived class. But we have a problem here, which says that object of abstract class type called Android is not allowed, and the reason for that is because pure virtual function called take a selfie has no overrider, which means that we are not obeying the rules of this contract here, which says that whoever signs this contract will have to provide the implementation for this function here, and our Android class is not doing that. So now we are not able to do this unless we implement this functionality here. So let's do that. Let's say public. Okay, and what I want to do is I want to implement a function called take a selfie, like this. So this take a selfie function will have very complex logic and very complex implementation in real life, but for demonstration purposes I will just write out that Android took a selfie. So I will say cout, and then let's say Android, like this, and then let's say selfie. Okay, so let's say that this is the implementation of take a selfie function. So now, as you can see, the error has disappeared, and what I can do now is I can say smartphone 1, so S1, and then take a selfie, like this. And keep in mind that we use this symbol here instead of dot when we want to access members of a class when this object here is a pointer. And in this situation, this here is a pointer, so in order to access the objects of its class, we use this symbol here instead of a dot. Okay, so if I run this program, let's see what will happen. Okay, I believe that this is too small for you to read, so let me fix that. This is readable now, and it says Android selfie. So let's close the console and let's do another thing. Let's say, for example, that another company wants to make their own smartphone. So let's create an iPhone, for example. In order to do that, I will create a class called iPhone, like this. And this iPhone class will also have to sign this contract here. So it will have to inherit publicly, okay, public from this smartphone class, like this, which means that it will have to provide its own implementation for this pure virtual function. So let's copy this code here, and then we are going to change the implementation. I will say that inside iPhone class, take a selfie means that iPhone is taking a selfie. Of course, this is going to be a very complex logic in real life. This is just for demonstration purposes. But one thing that I have achieved with this is that for my end user, so for someone who wants to use a smartphone, he does not need to know anything about how Android takes a selfie or how iPhone takes a selfie. The only thing that is going to change if he wants to use an iPhone instead of an Android is this part of the code here. So now we are just going to say that our smartphone called S1 will be equal to new iPhone, like this. So now if I run this code, as you can see, everything works as it should, but this second implementation is invoked. Okay, so it says iPhone selfie. So let's close this. Now, another thing that we have achieved with this is the following, and this is the true importance of abstraction. So now the developer that works on this Android class does not need to know anything about this iPhone class. The only thing that this developer here, so Android developer, needs to know is that he needs to provide the implementation of this function here for Android. Okay, and then our iPhone developer does not need to know anything about how this Android class works, but the only thing that he needs to know is how iPhone takes a selfie. So the only thing that he needs to implement is this logic here. And then for our third developer that works on this code here, he does not need to know how Android takes a selfie. So this part is hidden, this complexity is hidden. And then also he does not need to know how iPhone takes a selfie. This complexity is also hidden. The only thing that he needs to know is this abstraction here. So he only knows that if he wants to use a smartphone, he can take a selfie, and someone else is going to provide that complex logic of how selfie is taken. So he can use this functionality here without worrying about the complex details of how that functionality is implemented. So let's say, for example, that we receive a new request that says that every smartphone will need to have the functionality to make a call. So what that means for this contract here is that we will need to add another rule to this contract. So we will need to add another pure virtual function to this contract here. So I am going to copy this pure virtual function and I will just rename it so that it is called make a call, for example. Okay, and then what this here means for our Android developer is that Android developer will need to provide the implementation of making call for Android devices. So let's do that. I am going to copy this function here, and then I will change the name so that it is called make a call. And the implementation of that function will be, for example, Android calling, like this. So this here is going to be the job of our Android developer, so of developer who works on this class here. And he will not need to worry about anything else except the implementation of this function here. So let's close that. And then the job of our iPhone developer will be to provide the implementation of this function for iPhone devices. So let's do that now. I am going to copy this function again, and I will call it make a call. And then the implementation for make a call inside iPhone class will be iPhone calling, like this, for example. And then again, our iPhone developer, so developer who works on this class here, will only have to worry about the implementation of this function. So he does not need to know how Android is going to implement the same functionality, nor how the users are going to use this functionality here. So again, I am going to hide this complexity. And then our third developer who works on this code here knows that the contract has changed. So now every smartphone has this functionality here as well. And the developer who works on this part of the code here does not need to know how this functionality is implemented inside this class, nor this class. He only knows that now every smartphone can make a call. So what he can do is he can say smartphone1 dot make a call, like this. And everything should work as expected. So if I run my program now, okay, as you can see, it says that iPhone is calling. Okay, so what we have achieved by using abstraction is that now we have this contract here called smartphone, and this contract represents an abstract layer which says the following. Hey, all the developers who want to use a smartphone, here is a list of all the functionalities that smartphones have, and you can use those functionalities without knowing the specific details on how those functionalities are implemented. And then for all the developers who want to make their own smartphone, you will have to provide the implementation for all these functionalities here, and that implementation will be hidden in the background so that whoever wants to use a smartphone does not need to know anything about those complex details which are hidden. So now Android developer only works with his part of the code, and then iPhone developer only works with his part of the code, and then whoever wants to use this smartphone does not need to know anything about Android implementation nor iPhone implementation. He only needs to know about this contract here. So I hope that this video helped you to understand the idea of abstraction, which is the idea of hiding complex details behind simple procedures. So you make a class and then you provide an interface so that whoever wants to use your class does not need to know anything about complex details of how certain functionalities inside that class are implemented, but he has a very simple interface which says, hey, here are all the functionalities that you can use, and here is a simple way for you to use those functionalities. Okay, so again, if this video was helpful, please give it a thumbs up because that helps me a lot to reach more people. And if you would like to see more videos like this one in the future, subscribe to my channel and click the bell icon, and you will get a notification from me every time that I publish a new video. And then also, if you have any questions or any topics that you would like to see in the future, feel free to leave those in the comment section and I will make those videos in the future. So thank you very much for watching, and I am going to see you in some other video. Bye!